Let's do more elaboration on the topic of maximal flow problems with doing a case. Okay, now we have this city network between 1 and 7. That 1 is entering and 7 is leaving point. We want to see what is the maximum capacity that this network of roads can handle, and also this model gonna tell us how much each road must take, because as you remember, I told you maybe even we are gonna remove or turn off some of the roads, some part of the network, some pipes, according to the answers that we get from our mathematical model. Okay, the plan is to build a mathematical model of the discussed case, because in that case you are going to learn about these models much better. Okay, here in activity 1, because we want to create a mathematical model of this case, the first question is that what are the decision variables? I'm going to give you some examples before you pause the video and start thinking about that. Now, when it asks about decision variables, like always, you should ask yourself, you should tell yourself, decision variables are the things that you are expecting the model to tell you. Okay? In the case of shortest route problem, we just wanted to know which road to take. But here, not only we want to know which roads must be taken or which roads must be considered while we are trying to find the maximum capacity. Also, we want to know how much load must be put over each road. For example, if we have road 35, if the model tells us, okay, take road 35, it's not enough, because road 35 has the capacity of 3,000 vehicles per hour. We want to see, okay, when we consider 35 as an active road, how much load must be put on this road. Why it is the case, my friends? Just imagine we have 2 points, 2, okay, and from 1 2, and we have from 1 to 2 roads. One of them has the capacity of 8 and one of them has the capacity of 6, and after that it goes to 3. So when it is like this and the capacity of this road, for example, assume it is 10, you see, for getting the maximum capacity for this system, you must get the capacity of 10,000 vehicles per hour between 1 and 2. So you are going to define it like this. For example, you say that on this one we get 8, and for this one we are going to get 2. So you see, you don't have to take the maximum capacity of each road, because sometimes they are limited by the roads that are coming after them, and since we don't want any queue or line at the connecting part or connecting nodes of these roads, we should control these things. For example, we can assign it 5 and we can assign 5 to this. And don't worry about these things, because the mathematical model with its magical mathematical power will answer all these questions. So with all this introduction that I told you, you should now have an idea what the decision variables are. The decision variables must specify for us that which road and in what capacity. So I'm going to give you time, so please pause the video and make sure you put full explanation for the decision variable you come up with. Let's check the answer together. The decision variable you have defined must be controlled if a road must be taken or not, as well as the capacity of the road. In fact, it is very similar to the, for example, production modeling that we had before, standard bag, deluxe bag. If you remember, when we were talking about this problem, we said the decision variable must specify which product must be manufactured and in what quantity. So when we defined it as, if S was 0, in fact it is said don't manufacture S. If S was 10, it means manufacture 10 standard bag and so forth. So the best decision variable that we can define is this xij, double subscripted variable ij, and it talks about amount of traffic flow from node I to node j. So here, with this graph that you have in front of you, you must be able to define all the decision variables that we need to define the rest of our modeling. For example, we start with x12. What is x12? X12 is the amount of vehicle or traffic assigned to road 12. So if x12 is 0, it means that it is in fact of the network. It's not gonna handle any of the traffic burden on this network. Or if x12 is, for example, 2.5, it means that this road is gonna work at 50% of capacity. And like that, we continue to define all the decision variables, x12, and x13, x14. After that, we go for x2, 3, and x25, and like that, it continues. And now we have the decision variables. That is the amount of traffic flow from node I to node J. Now that we have the decision variables, it would be easy for you to define the objective function. Remember, the objective function is to maximizing something. When I say it is easy, I mean in terms of concept, but in terms of modeling, it is a little bit challenging. So take your time, try your best to write down the objective function. And remember, the objective function, my friend, is the maximizing the flow between 1 to 7, my friend. Okay, so it is not like that. For example, you start writing 5 times x12. No, it is not like that, because 5 is the capacity. In fact, it is some sort of 5. It's something related to constraint. It is not something related to objective function. It's different from the previous one. In the previous model that we did, the shortest route, the numbers that we saw on the arcs was the distance, and we wanted to minimize it, okay? But here it is the capacity of the road. So it is not something that you can put in the objective function. I just wanted to give you the hint, so in your trial and error, you do your practice in a closer area to the correct answer. Okay, pause the video and try your best. Let's get the objective function for this activity. The objective function that in terms of concept is very easy, but in terms of modeling a little bit challenging. When I show you the answer as the objective function for this problem, if you have done it, if you had done it correctly, be proud of yourself, because as I told you, it is not very straightforward. Okay, let me give you the second hint regarding the objective function. Regarding the objective function, you are gonna maximizing the flow from 1 to 7. Okay, flow from 1 to 7, we don't have any arc between 1 and 7, but the flow that goes inside 1 and gets out of 7 is in fact the flow that we have here, because the flow that we get from 1 to 2 plus the flow from 1 to 3 plus the flow we get into 1 4, all of the things are gonna inside the network and finally get out of here. So the objective function for this example is in fact is maximizing this input flow, because the input flow equals this output flow. Makes sense? If you remember, we said that there is no waste at any of these intersections, at any of these connecting nodes. So when it goes inside the flow, it gets out, and we want to maximize this. You agree with me? So what this equals to? This one equals to summation of these three flows. Please feel free to ask, please feel free to contact me if you have any question regarding this part, because it is something that we are discussing for the first time. So if you think it doesn't make sense, do not hesitate in contact me. But let's do it another time together. See, we want to maximize the flow that goes inside 1 and gets outside 7. So it is, and this is. And you agree with me, these two big arcs that or these arrows that I have drawn here are equal to each other, and when it gets inside, according to everything that we have discussed before, this big arrow that goes inside 1 equals to 1 2 plus 1 3 plus 1 4. So we have the objective function as this one that you can see. So it says maximizing t equal x12 plus x13 plus x14. What is this t? This t is the inside one, or let me tell you here. If we have 1 here and we have 2, 3, and 4. So anything that we get into 1 equals to these two things. So it would be enough to write x12, x13, and x14. And if it is confusing you about t, even don't consider t. Just write maximizing x12 plus x13 plus x14, because it is equal to the flow that will get out of the node 7. Now you have the objective functions, you have the objective function. After we did the objective function, we start doing the constraint. As we have talked about it before, for each node, you have a constraint, and it starts the constraint with node 2. But you may ask why we don't start from node 1. We are going to handle the constraint regarding node 1 and 7 finally after we do all these transshipment nodes. So if you remember before, we said that when we are dealing with network models, for each node we have a constraint. For here it is a little bit different but very similar.